sklearnmetricsbrierscoreloss. Description: the Brier score, also known as the Brier skill score, is a proper scoring rule that measures the accuracy of probabilistic predictions. It is typically used in binary classification tasks where the predicted probability of an event occurring is compared to the actual outcome. Inputs: y true. This is the array of true labels representing the actual outcomes of the events. It should be a binary array where 0 represents the negative class and 1 represents the positive class. Y-prob. This is the array of predicted probabilities for each event belonging to the positive class. It represents the model's confidence in the prediction. Outputs: score. This is a single floating point value that represents the Brier score. Lower values indicate better performance, with a perfect score of 0 indicating perfectly accurate predictions. Steps: calculate the squared difference between each predicted probability and the corresponding true label. Sum the squared differences over all instances. Divide the sum by the number of instances to obtain the Brier score. Metrics: mean squared error MSE. The Brier score is essentially a specialized form of MSE, where the predicted values are probabilities and the true values are binary labels. Visualization plots. Scatter plot. A scatter plot can be used to visualize the relationship between predicted probabilities and true labels. Calibration plot. A calibration plot is a helpful visualization for assessing the model's calibration. It shows the predicted probabilities against the observed frequencies of the positive class. Fine-tune parameters. None. There are no parameters to fine-tune within the Brier score loss function itself. However, it depends on the underlying model that generates the probability predictions. Fine-tuning the model's hyperparameters can indirectly influence the Brier score. Uncertainty methods. Confidence intervals. Confidence intervals can be calculated for the Brier score to quantify the uncertainty in the estimate. Challenges and fixes. Challenge 1. The Brier score assumes that the predicted probabilities are well calibrated. If the model produces poorly calibrated probabilities, the Brier score may not be a reliable indicator of performance. Sample use case that resulted in challenge 1. A model that consistently underestimates the probability of the positive class. Fixes to challenge 1. Use calibration techniques, such as Platt scaling or isotonic regression, to improve the calibration of the model's probability predictions. Challenge 2. The Brier score is sensitive to class imbalance. In imbalanced datasets, the score may be dominated by the majority class. Sample use case that resulted in challenge 2. A dataset where the positive class is much rarer than the negative class. Fixes to challenge 2. Use weighing schemes to assign more importance to the minority class during training. Consider using metrics that are less sensitive to class imbalance, such as the balanced accuracy score.